Welcome to the Explainer. Today we are diving into a concept that sounds like a total contradiction, but it's actually at the very heart of a huge technological revolution. We're talking about why some of the most secure systems in the world are built on an idea called trustlessness. So let's get into it. Right off the bat, here's the big question. It just seems to defy logic, doesn't it? How on earth can you remove trust from a system and somehow end up with something more trustworthy? Well, the answer is pretty fascinating, and it all comes down to redefining what we even mean by trust in our digital world. So, here's our game plan for getting to the bottom of this. We're going to start with the trustless paradox itself. Then, we'll look at the problems with the systems we trust right now. After that, we'll see how blockchain builds trust with code instead of people. And, finally, check out where this tech is already making waves and what might be coming next. All right, so Section 1, the trustless paradox. The main idea here isn't about getting rid of trust completely. No, it's really about shifting where we place our trust, moving it away from people who can make mistakes and putting it onto technology that's predictable. And this is the absolute key takeaway. Trustless does not mean there's no trust involved. It just means you don't have to trust a specific person or a single company. We're basically taking out the human middleman, the bank teller, the corporate administrator, and we're replacing them with something that can't be biased, can't have a bad day, and can't be bribed. Just pure, transparent code. To really understand why this shift is such a game changer, let's take a closer look at the risks that are kind of hidden inside the systems we use every single day. Our traditional systems, they have some serious built-in vulnerabilities. I mean, think about it. A single bank server can crash, and that's a single point of failure. A central database is like a giant honeypot for hackers. And a lot of the time, we have no idea what's really happening with our data or our money behind closed doors. It's this lack of transparency that trustless systems are designed to fix. So if we're moving away from trusting people, what are we trusting instead? Well, blockchain's answer is a whole new model that's built on something else entirely, code. And this is what we call a trustless system. So instead of just hoping your bank processes your transaction correctly, your transaction gets broadcast to this huge network of computers. And all these computers follow the exact same set of rules, a rule book that's totally public and can't be secretly changed by anyone. And they all work together to verify that your transaction is legit. And the difference is it's really striking when you see it laid out like this. On one side, you've got the old way, where the bank is this required gatekeeper. On the other side, the bank is just gone. The network itself is the intermediary, and our trust shifts from a company to the code that runs the whole show. So how does this actually work? I mean, how can a network of total strangers, with nobody in charge, create a system that's even more trustworthy than a bank? Well, it all comes down to three core pillars. These are the three ingredients that work together to create trust without needing a trustee. You've got decentralization, which spreads out the power, cryptography, which locks down the data, and consensus, which makes sure everyone on the network agrees on what's true. Let's break each one down. Okay, first up, decentralization. Imagine instead of one master ledger locked away in a bank vault, there are thousands of identical copies of that ledger spread out on computers all over the world. This makes the system incredibly tough. There's no single server to hack, no single point of failure. To corrupt the system, you would literally have to attack the majority of the entire network all at once, which is a nearly impossible thing to do. The second pillar is cryptography, and specifically a process called hashing. Think of this like creating a unique digital fingerprint for a batch of transactions. If anyone tries to change even a single comma or a single number in that data, the entire fingerprint changes completely. This makes any attempt to tamper with the data instantly obvious to everyone. And this right here is where the chain in blockchain comes from. Each new block of transactions doesn't just get its own fingerprint, it also contains the fingerprint of the block that came right before it. This creates a cryptographic chain. So if a hacker tries to alter an old block, its fingerprint changes, which then breaks the link to the next block and the next, and so on. The entire network would immediately see this broken chain and reject the fake version. It's brilliant.
The final pillar is consensus. This is basically how the network agrees on what's true. With proof of work, which Bitcoin uses, miners use a ton of computing power to solve a really hard math problem. The winner gets to add the next block, and all that work makes it incredibly expensive and difficult for an attacker to try and rewrite history. Then you have proof of stake, which Ethereum uses. Validators lock up their own crypto as collateral. If they play by the rules, they get rewarded. If they try to cheat, they lose their money. In both cases, there's a really strong financial incentive to be honest.
Okay, so we've gone through the theory. Now for the fun part. Let's see how these trustless systems are already being used out in the real world. The original and, of course, the most famous example is Bitcoin. It was the very first system that proved you could have a global, person-to-person digital cash system, letting anyone, anywhere, send and receive value without needing a bank's permission. But it goes way beyond just payments. Now we have this whole new world called decentralized finance, or DeFi. This uses something called smart contracts. Think of them like digital vending machines that automatically run when certain conditions are met, to build an entire financial system for lending, borrowing, and trading right on the blockchain, with no traditional banks in sight. And NFTs use that exact same smart contract technology to deal with digital ownership. They give us a way to prove without a doubt that you own a unique digital item. When you buy an NFT, the smart contract just automatically handles the ownership transfer to your digital wallet. There's no central registry, no third party you have to trust to verify it. So, what's next on the horizon for this technology? Let's take a look at the future of trust, and that includes some of the big challenges that are still ahead. Now, it's really important to be realistic here. This technology is not a magic fix for everything. It's facing some real hurdles, like getting fast enough to handle tons of transactions, dealing with the energy use of some networks, and the very real risk of bugs in the code that can lead to huge losses. And it also brings this new level of personal responsibility. You are your own bank. That means if you lose your private key, your funds are just gone, forever. There's no customer service to call. But, and this is a big but, the innovation in this space is just relentless. Developers are working around the clock on solutions to make blockchains faster and cheaper. They're building bridges to connect different networks, and they're pushing the idea of what trustless systems can even do, from decentralized social media all the way to digital identity that you control. And that brings us to our final question. The ability to replace this flawed, human-based trust with verifiable mathematical certainty is, well, it's a massive shift in how we think. We've seen it applied to money and to art, but what else is possible? Secure voting? Transparent supply chains? This technological revolution is really just getting started.